really see in there. Oh, looks like it might show up pretty good. The casting inside is pretty rough. There's supposed to be a little lip on the bottom there where the bearing surface kind of ends. There's supposed to be a cast lip there that stops it. It's pretty well corroded away. Sandblasted it in there to show the rest. So what I'm going to do now is make a flat spot on the bottom so that this is a little weep hole. If the seal starts leaking, it'll come out there. This is a water pump on the John Deere 50, and rebuilt one is $120 with a core exchange, which this core might have been alright, but it's $50 for a core, so it'd be $170 for an aftermarket one. John Deere gets close to $300 or $400 for them. I can get a rebuild kit for I think it was about $70, and that actually comes with new bearings, a shaft, and your new seals and a little carbon washer that goes in there. The bearings in this one are actually, it was probably good enough, but there again, since it's a part, I like putting new in instead of sticking with what's there. And had I known that was broke out inside, I might have just left it, hoped it, and I would have had to replace the whole pump. But this way I've got it set up in the mill, and I'm going to bore out the bottom of the hole in order to straighten it out so I can make a spacer to go in there and cut a slot in it for the weep hole and see what happens. That way the bearing can't move down, so the impeller can't hit against the radiator itself when it's on the tractor. And then press the impeller back on, press the pulley on, get a coat of paint on it, we're ready to go on the tractor finally. I won't be able to see much there, but I'll show you when I get her done. A little more than that yet. Doesn't really show up real well, but gives me a big enough flat surface where my spacer will go down tight against it. And then, like I say, once I get the spacer in, it's going to be a press fit in there, and then I'll cut the hole, the slot for that weep hole, to get the camera in the right spot. And I'll cut a slot through my spacer for that. And then once the bearing's in, it can only go down against that spacer, so it won't let the impeller move towards the... There's one spot over on the side where I just stuck my finger in there that is a little rough, but that's where the weep hole goes. Had a little chatter in the one edge by the looks of it, but it looks pretty good otherwise. Flat enough where the bearing will, or my spacer will set flat on there, so the bearing's got an even pressure and it's even there. Should be good enough. I've just got to figure out how thick to make the spacer. So if it ever leaks through the seal, this actually sets on here a little farther. You got to look in the book to see what the spec is for it. But if the coolant ever starts coming through the seal by the impeller and it comes up to this, well, this little slinger makes it sling out the weep hole so it doesn't get to the bearing. So once you see a little coolant coming out of that weep hole, it's time to either rebuild the pump or get a new one again. With this shaft in there that way, once you press it in, like I say, I wanted a spacer to keep it from going all the way down, since that lip that they had in it from the factory isn't there. So that should work. Now I'll get set up and make a spacer and get her all pressed together and ready to go. Okay, just got my Lufkin depth gauge out here and got her set in there where I'm touching what I machined down there, checked it all the way around, looks real good. Then I'll just have to measure to my ring groove up here and measure the new bearing and see what the dimension is. Go from there. Yeah, this is a new shaft and bearing. My hole depth is 2.125, so 208 inches deep. The bearing's a 1.532, and to the bottom of the snap ring groove, which if I would have had Adam Booth's little micrometer that he just showed in his, I believe it was the last Saturday night special, I'll have to look it up and see. It would have been great to measure that ring groove and the distance, well, the width of the groove plus the distance from the top to the bottom of the groove, which you could measure with his micrometers he was showing in response to Tom Lipton's video. Anyway, I ended up with 260 to the bottom of the ring groove. So that gives me 333 thousandths is what my spacer needs to be. Got a little coffee can full of a bunch of other stainless, and well, different ones got high carbon steel in. This is most just hot, maybe cold or old both. Had a piece in there. Well, all these have got a hole in. I've got another one with just pieces around. And this one happens to be the exact OD I need. In fact, I couldn't ask for a nicer fit than that. There's maybe 2 thousandths clearance. I doubt any more than that. I didn't actually measure it yet to see. And the hole does need to be quite a bit bigger. I'm only, now I think the OD is 1.182, I think is what I've got written on my sheet here. And the ID is 1.009. So it's going to be a pretty thin wall piece, and I only need 333 thousandths for length for the spacer in the bottom of this hole then. And then the actual bearing, well, the bearing will set in there on top of that spacer. Just to make sure it can't travel down so the impeller can't hit the radiator housing itself. When you press the impeller on the other side, well, I'll try and do that in the video too. You press it until the highest tooth on the impeller. Okay, this is what the impeller looks like. This is the side that goes towards the radiator, so when you press it in, the highest tooth on here you want to have slightly below flush on the bottom of this housing. And like I say, I'll show that when I press it in. This is where a little carbon washer goes in, and the seal's underneath that to seal it. But I'll show all that when it goes together. Right now we're going to set up in the lathe and bore this guy out to size, and cut her off, and then we got our spacer done. Actually had a piece of 1.5 inch stainless in here I was going to use. And then remembered to look through the can I had. Well, in this piece, so it'll work a lot nicer. Okay, I took a facing cut on it, measured the hole diameter, and we're at 750 there. So I've only got to go up to 9 thousandths over 1.009. Figure 50 thousandths cut, 100 off, add 100 to the diameter. 950 towel cut. It should put us at 950, and we should only have about 59 more to go. Just feeding it by hand for the short little distance I have here. I'm going to move the camera a little. Looks like the stud's in the way you see. The 1009 is actually the exact size of my slinger. So I need clearance for that. Yeah, it's giving about 18 thousandths clearance right now. Might go a little more than that. Should be fine. Okay, you took the file and knocked the edge off, a little piece of sandpaper, and cleaned the edge out in there, so should be ready to cut her off. I'll probably leave it a few thousandths long so I can deburr the other side, and I can take it in the sandpaper and the flat surface and clean her off that way a little. Just, well, as thin as this is, I shouldn't need to. I'm going to anyway. I need 333, so I'll probably go like 334 or 5 just to give me a little room. Here for the hell of it. Something this small and thin wall, you definitely can't tighten very much in this lathe. It's a big chuck like this, that's why it'd be better in the south bend. But since I've got the camera set up here, figure we'll experiment and see what happens. Probably knock it out of there or bend it, but I've got enough to make another one. A little wobble this way, but it's actually not too bad the other way. I'm only going to shave it down close and then I'll true it up. Then about the 2 thousandths I was looking for originally. So I'll just sand her down a little bit, and we should be ready to put a pump together. Okay, you can see the spacers in place. You can see a little gap, it looks like, along the side towards the flashlight there. That is actually where the casting was broke out inside. She fit perfect, and we'll find out if it's the right length now. You got the little slingers on here. I checked the book and it's supposed to be 1 39/64 inches from the end to the edge of the slinger. So that's set where it's supposed to be. And feels like you got to tap it in a little bit. Not too good left-handed. In fact, the whole thing's moving, so I'll have to set it down and do it. Well, tapped her down in, and looks like we're perfectly flush with that ring groove in there. But at least my math worked on that part. So put the snap ring in, and then press the impeller and the pulley on, and she's ready for some paint. May not show up in the camera too well, a little dark over there, but a little more than that. And the pulley, you just press it down flush. And we'll get the impeller ready to go, and we can put that in. On the impeller, I cleaned it out a little bit inside. This is a seal and spring that goes in there. And then this is that little carbon washer I think I mentioned earlier. It actually goes in and keeps pressure against the two sealing surfaces. I bent a little piece of metal to hopefully help hold it in place. Which will basically hold it into these notches that are in here. And then you set your pump down into it. Is the way they suggest to do it anyway. I don't remember what we did on the last one, but
Let it on? Oh, yeah.
okay, this is the upper coolant tube with a John Deere 50. Over the years, well, she's got a little pinhole here. I think there was a couple of them in there if I remember right. It's only about 80 thousandths wall tube in the first place. And they've got a pretty good curve on the end of it here because it slips into a couple O-rings. The O-ring sets back here where this line is. And they slip into that. And there's actually another pinhole right there even. But anyway, the John Deere gets over 300 bucks for this tube. It's 20.5 inches long. Well, I got some 83,000 stuff here. That is 2 3/4 OD. So it's the same OD. This is a DOM tube, so it's got the flattened out welded seam. And what I'm doing now is I've got a bearing race that I turn to the right size, and I'm putting it in the press to taper that end. I was going to do it, well, I thought of a couple different ways before, but I'm going to try this way. I did start to do it a little bit. It looks like it's going to work. So since it's going to work, I figured I'd show you guys. Now it won't work. I did oil the race up good and everything that way. That's why I'm just hand feeding it down too, that I don't want to use the air on here, 'cause I don't know if that's showing up in the camera, but it does have about the taper I want. I think I'll try going a little more since I've got the room in here. I can go down, you know, about another 150 thousandths yet. So. Put this piece of tube, I got a 4-foot long piece off eBay. It's actually something they use for a muffler pipe, and I think it was $46 for the 4-foot piece shipped to the door. That looks real good, and that'll give me the clearance I need to go through the O-rings are, oh, I think they're about 300 thousandths thick. They might be a little bigger than that. So I want to make sure this edge doesn't catch it all when you're putting it into the cast piece with that O-ring in, so you don't slice your O-ring. Then it'll give you a nice tight seal on the rest of it back here. I do have room to curl her just a little more. So put a little more oil on here. The race is actually smooth enough inside that I probably don't need the oil on it. I'd rather be safe than sorry. A little oil is better than a screwed up piece. Looks like it's down pretty even all the way around. I like that better. That's closer to what the original taper is, if it shows up in the camera there. Find out when I edit, I guess. Now we can do the other side. The other end. As you can see, it's now we got better than 1/4 inch that the race will go down in order to shape her. And using the bearing race like that and make sure that I'm ending up a nice round even surface too, which will help me more. The way I was going to do it is about like the metal spinning or something that way. That's the problem with this press. This is just that cheap Harbor Freight one that it's got a lot of play in it. That's about where we were on the other end. I like that. Not bad for a little time, and 20 bucks worth of pipe compared to 310 bucks. I'll get her painted and get it on the tractor.